Two small balls with masses m1 equal to 0.4 kg and m2 equal to 0.2 kg approaching one another with speed of 0.3 meter per second and 12 meter per second respectively. Completely inelastic head-on collisions takes place between the balls and heat Q is produced. Find the Q. We let the ball 1 move to the right and the ball 2 move to the left. The ball 1's mass m1 is 0.4 kg and the mass of the ball 2 m2 equal to 0.2 kg. The velocity of the ball 1 is points to the right with the magnitude 3 meter per second, u1, and then the magnitude of the ball 2 is the velocity of the ball 2 is points to the left with the speed of 12 meter per second and denoted as the u2. Now bear in mind that we will take the horizontal directions that points to the right as a positive and points to the left as a negative. So since we know the informations about the m for both balls and the informations of the speed for the both ball, then we can find out what is the kinetic energy of the ball 1 and the kinetic energy of the ball 2 before they collide between one another. We should have this k1 equal to half m1 u1 square and the k2 equal to half m2 u2 square. Now after the collisions, the head-on collisions, these two balls will stick together because it is the completely inelastic collisions. So these two balls will combine together after the collisions, and if we know what is the final velocity of them, which is shared by these two balls, then we can find out what is the kinetic energy of the two balls after the collisions. So we denote this final velocity of the system as a k12. So don't forget about to add up the masses of these two balls because they already stick together. Okay, so if we are able to calculate what is a k1, what is a k2, and we know what is a k12, then we should be able to find out what is the change of the kinetic energy to get the heat produced due to the head-on collisions. Look at these equations. K1 plus K2 is the sum of the total kinetic energy before the collisions, and this K12 is the total kinetic energy after the collisions. So the differences between these two indicates that there is a kinetic energy loss due to the inelastic collisions. This kinetic energy loss will be transformed into the heat, which is denoted by the Q. So our aims is to find what is the heat Q. But the problem is now we need to know what is a V to find out the K12. The information of M1, M2 are given in the equations. You see U1, U2 also given in the equations. So now the only informations that we don't have is a V. So if we can find a V, then we should able to find what is a Q. So how to find a V? That means the common velocity of the two balls after they encounter the completely inelastic collisions. To find that, then we need to apply the principle of conservation of the momentum. This is the conservation of momentum equations. M1 U1 plus M2 U2 equal to M1 plus M2 V, where the V is a common velocity after the collisions. Okay, so if we change this V as a subject, we have these things at the right hand side of the equality sign. So you can see all these symbols, the values we know from the equation is given in the equation. So that means we can find out what is the velocity of the two balls after the collisions by applying the principle of conservation of momentum. So if we have this V, we substitute into this formula for kinetic energy, then we should be able to find what is the change of the kinetic energy of the system, and that change of the kinetic energy system will give you the heat that we want to find out. Now let's start the mathematical calculations. We have the Q equal to K1 plus K2 minus K12. So now we substitute all these expressions of the kinetic energy before and after the collisions. This one is K1 is half m1 u1 square, K2 is half m2 u2 square, and the K12 is half m1 plus m2 times the v square. Again, this m have to we have to add it up because after the collisions, the ball 1 and ball 2, they combine, they stick together. That's why to calculate the its kinetic energy, we have to consider the total mass because they already combine together. But the v, the common velocity of the balls after the collisions is given as this. This expression, as explained just now, it is it is obtained from the applications of the principle of conservation of linear momentum. We have this v in terms of m1, m2, and u1, u2. We can simplify the third line equations by cancel out the m1 plus m2, this m1 plus m2, and here you have this m1 plus m2 square. So we can cancel one of it to get the denominator as m1 plus m2, and then this numerator in the bracket, we take the square and we expand it. We'll get the m1 square u1 square plus 2 m1 m2 u1 u2 plus this second term square, which is m2 square u2 square. Next steps, we try to get the common denominator for these three terms. Okay, so that means the first term and the second term, we have to multiply both the numerator and denominator by the m1 plus m2. First term and second term same, m1 plus m2, m1 plus m2. So now we see that these three terms, all the denominator are the same. Now if we expand, look at this line, if we expand these terms, the first term, numerator of the first term and the numerator of the second terms, and then we minus the numerator of the third terms, we will get this answer. Okay, please look at, we can try to check. You see the first term, m1 u1 square times the m1, then you will get m1 square u1 square. So these terms would be cancelled with the first term of the first numerator in the third terms. So this one and this one cancel. And then for the first terms of the first numerator in the second terms, m2, sorry, it should be the second terms for the numerator of, second numerator of the second terms, m2 square times u2 square would be cancelled with this third numerator of this third terms, m2 square u2 square, because of the minus sign here. So that means we will have the this m1 m2 u1 square, and then m1 m2 u2 square, and then minus the middle term, the second numerator of the third terms, which is 2 m1 m2 u1 u2. So if you look at these three terms of a numerator, that means we can factorize the m1 m2, okay, m1 and 2, and then this u1 square plus u2 square minus 2 u1 u2 square, 2 u1 u2 can be factorized to get this u1 minus u2 square. Now is the time to substitute value. For m1, the mass is 0.4 kg, m2 is 0.2 kg, and u1 is velocity of the speed, velocity of the mass 1, so it is 3, and then the u2 is a velocity of the ball 2, which is moved to the left before the collisions. So don't forget to substitute u2 by the negative 12. That is why here becomes positive, because u2 is negative value, negative 12 times the negative, then that's why we have the positive value. Don't make this mistake. Here should be positive. And then divided by 2 times the m1 plus m2, 0.4 plus 0.2. So the final answer that we can get is the 15 joule, which is the heat Q produced. The heat Q produced in the process of the completely inelastic head-on collisions. Because in the completely inelastic head-on collisions, the kinetic energy is not conserved. That means the initial total kinetic energy for the two balls is not the same as the final kinetic energy of them after the collisions. So there's some kinetic energy loss, which is 15 joule that we can see now. And then this 15 joule actually will be transformed into the heat. That's why Q equal to 15 joule.